Welcome everyone, this is your math tutor Naresh. In this tutorial I'm going to introduce you to algebra. More specifically, we're going to talk about the language and symbols used in algebra. So let's get started. The first thing we're going to talk about is the types of numbers, and to do that I'm going to draw a number line. Start with 0 at the center. On the right hand side I can go up by ones, 1, 2, 3, 4, etc., and all the way to positive infinity, and this is the symbol for positive infinity. And on the left hand side I can also go up by ones, -1, -2, -3, -4, and so on, all the way to negative infinity. What are natural numbers? Natural numbers, they start with 1 and then they go up 2, 3, 4, 5, and so on. So these are natural numbers. Next, what are whole numbers? Whole numbers are all natural numbers, but they also include 0. So 0, 1, 2, 3, 4, 5, etc. Next, we're going to talk about integers. So integers also include negative numbers. So I'm going to start with 0, 1, 2, 3, 4, 5, etc. And then on the left side, -1, -2, -3, -4, -5, and so on. So integers can be negative numbers, 0, and positive numbers. Next, we're going to talk about rational numbers. Rational numbers are fractions. So for example, 3/5, and they can also be negative. So let's say -3/5. So this is a rational number. If I was actually to divide 3 by 5 on my calculator, what I would get is -0.6. And the point that I want to make here is that this division actually stops. So there isn't any other digit after the 6. Right? So the answer is -0.6. Now another example of irrational number is 1/3. 1/3, and again if I divided 1 by 3, what I would get is 0.333333 forever. The 0.3 repeats, and we show that repetition by putting a bar over the numbers. So 1/3 is 0.3 repeating. So rational numbers. So two things you should know. One, the division stops at some point, or can stop at some point, and here the numbers can repeat after the decimal. So this leads us to irrational numbers. So irrational numbers, also fractions. So for example, a fraction like 22/7. 22/7 is actually the exact value of pi. So if I was to take my calculator and divide 22 by 7, what I get is 3.142857143. So this is the number of digits my calculator is displaying. But what's interesting about pi is that the numbers, this is actually never ending. So you could do the division for the rest of your life, and then you will always keep on getting a digit after another digit and so on, and this is actually never ending. And another characteristic is that after the decimal the numbers don't repeat. Just like with the 1/3, they repeated, here they don't repeat. So these are the characteristics of irrational numbers. If I combine all of these, then these are what we call as the real numbers. So the number line up here, it represents all the real numbers, which are made up of natural numbers, whole numbers, integers, rationals, and irrational numbers. So now we're going to talk about symbols when we compare numbers. The first symbol we're going to look at is the equal sign, and we all know what an equal sign looks like. So that's equal to, and you would see if you were given something like this, 5 plus 3 equals 8. So here's a symbol and here's the use. And the next is not equal to. So we put a line through the equal sign and this becomes is not equal to. So again, if I use the same expression, 5 plus 3, and instead of 8 on the right side, let me make it 9. So 5 plus 3 does not equal to 9. So this is an incorrect statement. So we put a line through the equal sign, and now this statement is correct, that 5 plus 3 is not equal to 9. Next, we have an approximation symbol. So some books use this, others can use an equal sign with this curve on top or even a dot. So this is an approximation. So an example, let's say if we have a number like 3.49, and then another number that we're comparing is 3.5. So these two numbers, because they're different, so they're not the same. So we could say that they are not equal to. So we could say that they're not equal to. But on a second look, 3.49 and 3.5, they are approximately the same. They're pretty close to each other. If I was to round 3.49 to one digit after the decimal, to one decimal place, then this would round to 3.5, in which case it would be the same as what we have on the right side. So 3.49, approximately the same as 3.5, so this is where we can use the approximation symbol. So next we have less than. So less than, an example would be 3 is less than 7. And this symbol is greater than. An example would be, let's say a number like 10 is greater than 4. Now the symbol in this example, it opens towards the number 10. So whichever number it opens towards, that number is bigger. So 10 is bigger than 4. Now in this example here, it's opening towards 7, so 7 is bigger than 3. So that means 3 is smaller than 7, or 3 is less than 7. So next we're going to talk about the operations that we do with the numbers. So the first operation is addition. And the mathematical symbol is plus. So 2 plus 3 equals 5. So we've used the addition, the plus symbol. Next, subtraction. And mathematical symbol is minus. So 10 take away 3 is 7, or 10 minus 3 is 7. Next, multiplication. Mathematical symbol is times. So what's the product of 2 and 5? That means 2 times 5, and the product is 10. Lastly, division. And the mathematical symbol is this for division. An example would be, let's say, 8 divided by 3. So 8 divided by 3, what this translates to is that 8 over 3. We're dividing 8, so it goes in the numerator. We're dividing by 3, so this goes in the denominator. So that's something you have to memorize, that 8 goes in the numerator and 3 goes in the denominator. So this symbol here, it means 8 over 3, and if you wrote it as 3 over 8, that would be not correct. Okay. So now, later on when we do word problems, you will be given sentences, information in the sentences, and there would be words used which would represent addition, subtraction, multiplication, and division. So various words to represent the same thing. So some of the words for addition or other words are, the obvious one is add, and the next one is sum. So what's the sum of these bunch of numbers? Total, what's the total of these numbers when you add them? More than, so more than is also means addition. Raised, increased, and combined. So all these different words we will see later on when we get to the word problems, and when you translate from the word sentence to a mathematical expression. For subtraction, other words, the first one is obvious: subtract, minus, take away. I used the word take away when I did this example. Negative, lowered, decreased, and less than. For multiplication, so multiply, product. I used the word product. I said, what is the product of 2 and 5? So product means multiplication. And also the word of means multiplication. So when we go to a shopping mall, we see sale sign all over the place, 30% off, 40% off, 70% off. So then you may want to calculate what is 30% of the original price. So 30% of the original price, if that's the discount that you're getting, then off means multiply. So you multiply 30% with the original price. Division, divide, that's one. Another word is parts. So you have a pie that you want to divide into 4 parts, into 8 parts, into 16 parts, or however many number of parts. And another word for division is into. So into, so for example, 3 goes into 12 4 times. 5 goes into 15 3 times. All right. So some words to look out for when you work with the word problems. All right. So next we're going to move on, and I'm going to show you the square root symbol. So this is square root. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Here I'm not going to show you how we get these answers. You probably already know, but our focus here is just to introduce that symbol, and that symbol is called the square root. So next, this is the letter pi. We already talked about the value of pi. It is, the exact value is 22/7, and approximate value is 3.14. Pi is used when we work with circles in trigonometry, so later on you'll see the use, but right now I just wanted to introduce. Alright, the next thing I want to introduce is the absolute value. So absolute value is represented by these 2 vertical bars. So what's the concept here? Now, to explain the concept, I'll use a number line. So let's say you are here at the center, and you're going to walk 4 units away. So from here to here you walk, and the question I can ask you is, what's the amount of distance you traveled? You'll say, well, I traveled 4 units, 4 meters, 4 kilometers, whatever the units happen to be. So you walked 4 units of distance. Okay, so now if I say, what if you walked in the towards left, or in the opposite direction? -1, -2, -3, -4. So what's the amount of distance you walked? So now you're from there, from 0 to here. So when people work with number lines, then they get, is it 4 or is it -4? The question is, what is the distance you walked? I'm not asking about the direction you walked in. So we know you walk towards left or in the opposite direction compared to your original direction. So, but at this point, we're not interested in the direction, we're only interested in the magnitude. The magnitude is that you still walked 4 units of distance. So what we do is we take the absolute value of this, and then what comes out is positive 4. So 4 units. So the distance you traveled is still 4 units. So that's the concept of absolute value. So another example we can do, what's the absolute value of 6? When this number comes out of these bars, the answer is 6. Now, what about the absolute value of negative 6? So bring this out of the bars and it becomes positive. So that's the concept. The next symbol is the percentage symbol. Oops. Percentage means out of 100, and that's all I'm going to say at this point. I just want you to be aware of the percentage symbol. Again, when you go shopping, you see sale sign, 25% off, 50% off, 75%, and so on. So, alright. So that's all I'm going to say about the percentage. Now, in algebra, we also use letters, and we call them variables. So if we don't know something, for example, let's say a number that we want to find out, if we don't know what that number is unknown, we can say let x be the unknown number. So we don't know what that number is, so we just say let x represent that number, that unknown number. And now we can have expressions. So let's say 5 added to this number. So what I want to get across here is, how do we translate this sentence into a mathematical expression? The unknown number is x, so that's x, and now we're adding 5. So x plus 5. So this translates into a mathematical expression with variables x plus 5. Now another one, so I'll call that example 1, example 2. So 4 less than that number. So 4 less than the unknown number, so that would be x minus 4. So it's 4 less than the original number. So what I want to get across is how we translate the sentence into mathematical expression. And alright, so I'll do one more. So that would be, let's say, triple that number. So how do we triple that number? So it would be 3 times x, so 3 times x, so 3x. Alright, so I'm going to wrap it up here, and my purpose in this tutorial was to introduce you to algebra, more specifically talk about the language and the symbols that we use in algebra. So I hope you found this tutorial useful. If you did, please like or subscribe. And this is part 1 of the video. There is part 2 of this tutorial, in which we're going to do some homework question practice and applying what we have learned in this lesson. Thank you for watching, and we will see each other next.